Okay, so the next piece that we have. Is we're going to be dealing with graphing logs. So what I want to start with is I'm going to start by doing a review of how we graphed exponentials. So let's say, for example, we were dealing with the function. Let's do two different colors so they stand out a little bit more. Let's go back to the exponentials we did before. Let's say we were doing y equals 2 to the x. So what I had told you in class was what we want to do is we want to come up with a table of values. And what I had said is for those values of x, what I recommend you looking at is -1, 0, and 1. We plug those in. So what we would look at is we'd say y equals 2 to the -1, which is 1/2, because 2 raised to the -1 is a fraction. So -1 would be 1/2. Y equals 2 to the 0. Anything to the 0 power is 1. So this would be 0, 1. And they always have that 0, 1 in common. And then y equals 2 to the first. That's 2. So what we ended up saying was we knew we were at 0, 1. We knew we were at 1, 2. 1, 2. And we knew we were at -1, 1/2. So what we ended up having was for an exponential. This is kind of what our exponential looked like. This was our y equals 2x. And again, as a review, the domain of that was all real numbers. Again, this is a review of what we did a few days ago, I think on day 3. The range, in this case, what values of y can it take? Well, if we look at this, all the y's are positive. So this is y is greater than 0. The asymptote we had for this one was the x-axis. So it was y equals 0 or the x-axis. And this was a growth model. That was a growth model. So that's what we did before. I want to show you how what we're doing now connects to that. Now we're going to worry about graphing the log. So what we're going to do is we're going to graph log base 2 of x. So what I want to show you is the process we followed is very similar here. So I'm not going to teach you a set of rules to graph logs. What I'm going to teach you to do is rewrite this as an exponential. So this says take this number, raise it to that number. So 2 to the y equals x. So I'm going to write it down as x equals 2 to the y. And if you look here, looking at these two right here, notice the y's and the x swapped places. The y's and the x, the y was here on the left, the y is now here on the right, the x was here on the left, the x is now here. I'm sorry, the x is on the right here, the x is now here on the left. So x's and y's changed roles. So we're still going to follow that same idea of x and y, but here's what we're going to do instead. Over here, we put -1, 0, 1 in for x. We're going to put -1, 0, and 1 in for y. So again, follow that same logic. X equals 2 to the -1. So x equals 1/2. So this is 1/2. X equals 2 to the 0. 2 to the 0 is 1. So it's 0, 1, 0 here. And the last one, x equals 2 to the first. So this is 2. So what I want you to look at is look what happened to the points. The points changed. The x's and y's swap position. This was -1, 1/2. This is 1/2, -1. This was 0, 1. Now it's 1, 0. This was 1, 2. Now this is 2, 1. So if I go to plot this, I'm actually going to be plotting in a different point. So I'll plot that 1, 0. So this is 1, 0. 2, 1. 2, 1 is going to be here. And then 1/2, -1 is going to kind of be. So 1/2, -1 is going to be like right there. And what we're going to find out is that this curve is going to look like this. So what we have there is we have a new function. That is our exponential function. This is y equals log 2x. It's basically the same. It's the image. It's the reflection across this y equals x. Don't need to know that, but that's what it is. There's actually a line that kind of goes right here through the middle, and it's a reflection over, because if you kind of think about it, if I had folded this over, theoretically, it would just kind of map on top. So let's take a look at the domain and the range and the asymptotes here, because what I want to show you again is the following. X's and Y's change position. Notice the X's and the Y's change position. Well, the rules change positions too. The domain on an exponential is all real numbers. The range on a log is all real numbers. So that thing moved from the X to the Y. And now this before was Y greater than 0, because if we look at it, everything's above 0. The domain is X is greater than 0. So my greater than 0 moved from range to domain. My asymptote changes from Y equals 0 to x equals 0, from the x-axis to the y-axis. But technically, I still have a growth model going on here. I still technically kind of have a growth model kind of going up. So this is what we did today. We graphed logarithmic functions, and we followed the same pattern. And really what I wanted to show you is basically that what we learned was that the log is the inverse of the exponential, What it means is, since it's the inverse, the x's and the y's switch roles. So again, x's and y's switch position, the number switch position, the domain and range switch, the asymptote switched. So that's basically what we're dealing with when we're dealing with a logarithmic function. And so then what we did is we practiced graphing them. So what's going to happen on Wednesdays, we're going to do a review for the test. We'll have a little bit of this, a little bit of everything. Hopefully this helps. Please let me know if you have any questions, and we will talk soon on Wednesday.